Hello, everyone, and welcome to a new week's installment of the Routing Loop. I'm Alex. I'm a long-standing host of the Routing Loop here on Twitch, and I'm joined by Tom, who's even more long-standing host here on Twitch. But he's going to be playing today the guest role. So, Tom, how are you? How are things? Long time no chat, man.
Yeah, you've been gone for a long time, Alex. Do you want to share what you were up to in the last few weeks, few months?
Yes. I was gone. I was out for around 3 weeks on vacation, which seems like a very long time, and it seems like it's also been a very long time ago. But yeah, two very interesting things. One, I got married, so that's the first life-changing event, I would say. Saying hi to my husband.
Or maybe he's in the office
And
with me somewhere today.
yeah, I think probably at the different level. I don't know which level you're on, but he's on 22nd. Um, so yeah, I got married. I got on a 2.5 week honeymoon, which is not a whole month, but it was super nice. I went to New Zealand and Cook Islands. So I relaxed. It was really nice. And then I came back and now back to marathon training, running the Sydney Marathon in August. Did Beta Breakers this weekend in San Francisco. I don't know if you folks know about it, but it is actually the longest standing foot race in the world, dating back to 1912, I think.
Wow. I
So
remembered, it's funny because we were chatting just before we jumped on, and I remembered about the beta breakers, and I completely forgot about the wedding because
yeah.
if anybody hasn't seen beta breakers, it's super interesting. Everyone's dressed up, and it's like a race through San Francisco, and it's like some crazy stuff going on. Like I know there's a group of people that are running in the opposite direction, dressed up as
Yes.
salmon because
Sure.
they're
A
going
salmon. Yeah.
upstream, right? So all the very funny.
I have seen some of the craziest costumes ever this weekend. It was my first time actually participating in Beta Breakers, and I had no idea about the history of it. And then I was like, okay, I need to read about this bit, and it's really amazing. Like it's a party that involves the entire city. The course is actually from Ferry Building all the way to Ocean Beach, so it traverses the entire San Francisco width, I would say. And it's so nice because people come out of their homes, they start playing music. It's crazy. Yeah, love it. I totally recommend it. You should, if you're around during this time of year next year, you should absolutely do it.
Yeah, I'm not a runner, but I would go for beta breakers because I think you can drink while you're running. So
Oh,
that's
absolutely,
yeah,
absolutely. You can drink, you can do anything. You can also just walk it. Like there's people walking it. You don't have to run it.
yeah.
Um,
Can see that being
but
me with a beer, just walking, maybe taking my cat with me. Yeah, I can see that.
Yeah, yeah. You don't even have to get your own beer because there's people on the sides that are giving you booze and everything. So don't worry about that. Hydration included,
Yeah, perfect. Or dehydration.
or dehydration. Cool. But what are we talking about today? And I
Yeah,
think this is going to be a really interesting session.
yeah. In the age of AI, we are talking about the fundamentals, availability zones. It sounds very boring, I think, on the surface, but there's some interesting things that we want to touch on, and it comes up quite a lot actually with a lot of customers because the availability zones I think are well understood, but networking services have some kind of quirky ways they deal with availability zones.
Nice. Awesome. Okay. Before we dive into that, I want to say thank you to everyone who's joining us today on the chat. Let us know where you're coming from and where you're from. We see some longstanding folks here from uh, our fans. Should I say fans? Is that too overrated? I don't know.
Regulars.
Um, regulars. Yes. Good that I'm getting my words cleared out here. And thank you for the congratulations. I have to say. And the third thing, Tom and I were actually chatting before we went live that I was building a personal financial app agent yesterday, and I used without any commercials to anything. I used Perplexity Computer. to do this, and it just hosts it for you. Like I don't know about AZs. I don't even know where it is hosted. So there's such a big difference between that and us talking about AZs today, which is it's an interesting time we live in, I think.
Yeah, I guess someone needs to think about AZs those, right? Like, if it's not you,
Like
then the vendor has to think about AZs and how they
yeah.
set it up. Especially if you're an individual, you probably run on a single machine and do whatever. But if you're an enterprise, all of a sudden, you at least need to know what the vendor is doing with your AZs. How do they maintain availability? So actually, even in the age of AI, AZs.
Yep, yep, totally. Okay, so let's dive right in.
Okay.
I'm going to start asking you questions, by the way. I don't know if you have any plans for how you want to talk to us or if you want to do any whiteboarding. But I think it's for the benefit of everyone joining us. I would start with what are AZs?
What are AZs? Okay, I'm gonna use a whiteboard. I'm gonna use a whiteboard because then that way we can start from a common point. So first of all, we have a region, right? Region is where you decide to deploy your application, and within the region you will have distinct locations defined as availability zones. I'm gonna just draw three here as little blobs that are separated, right? So these are availability zones. And these are one or more data centers, physical data centers, when you actually deploy your applications, right? So there's going to be one or more data centers in each availability zone. And the way we are designing availability zones is those data centers need to be far away from one another, or data centers in different availability zones have to be far away from one another to avoid sharing fate during some larger disaster scenarios, floods, fires, earthquakes, anything you can imagine. They should be far enough away from one another to be able to still have some availability, even if one availability zone is completely down. Um,
Cool.
so pretty much availability zone is all about availability. So it's all in the name. And in this region, we have three availability zones. Majority of our regions have three. Some have more, like US East 1 has six, I believe.
I think
Uh,
7 at
seven
this
now?
point.
Yeah, wow. Yeah. I don't know.
It's A through F for sure. So how many is that?
Yeah. Yeah. It's got maybe seven. I don't
Yeah.
know if we have all the letters. Um, so when you deploy your application, right, I'm going to draw a VPC and I'm going to delete it. But if you deploy your application inside a VPC, right, a VPC is going to span in a region, and then availability zones are going to be your subnet. So if this is a VPC, this is a subnet and subnet. And by creating the subnets, you define which availability zone you're going to drop them into. Right. So your resources are going to live in here. Now, from a distance point of view, so I think we publicly say about like we're aiming at 60 miles, so roughly 100 kilometers, more or less, between different availability zones. Right, that's kind of the distance we want to make sure we have, and then that
This is
also
just to clarify, this is the design goal, right? So we want to
design goal.
make
That's
sure
right.
that by design we have this distance between availability zones. Is there a way we can find out like latency between availability zones? I think there's a service, right, in CloudWatch.
Yeah, there's a service in CloudWatch. There's infrastructure performance. Maybe I can just pop it up very quickly. See if I can
I can
find.
search for that.
Oh yeah, go on. Yeah, so there's a way to actually measure. So what customers used to do is there were these external dashboards where someone just put a bunch of instances in different AZs, and then they were sharing the latency metrics. Now there's a service, infrastructure performance, that will tell you roughly what's the latency between different AZs or between different regions. You can just pop into the console and pull that out.
Nice. That's so
Uh,
cool.
I
Okay.
think the design goal there is roughly, when we're talking or when we're thinking about cross availability zone traffic, that's usually 2 milliseconds.
Yep.
Right. So it's you could say insignificant for some scenarios, but very significant for others. So that 2 milliseconds might be make it or break it for some applications. And then the other aspect is there's also cost associated with data transiting between availability zones. right? So if we're passing traffic from one availability zone to the other, there's a charge on the out and there's a charge on the in. Like if we
Mhm.
look at it, let's say US, I think it's 1 cent per
Mhm.
GB on data out, and then 1 cent per GB on data in. So all in all, sending a gig from one AZ to the other, it's going to add up to uh, 2 cents per GB. The other thing, kind of very fundamental, before we even dive into any networking services and how they operate in AZs, is the naming. That I've seen it comes
Oh
up a
yeah.
lot, and it creates a lot of confusion, right? Because there's two things we have with availability zone. We have a name, and then we have an ID. The name is different across different orgs or accounts. You can think about it as randomly allocated. An ID is static and the same across organization, across AWS accounts. So if this is AZ1, which is the ID, anytime you see this is AZ2 and this is AZ3, these are IDs, and these would be the same regardless of which account are you in. But then on top of that, for account one, this might be AZB, this may be AZC, and this may be AZA. For another account, this may be AZA, this may be
Mhm.
AZB, and this may be AZC.
Interesting. Do you know why we are doing this?
I think I do. So people
What's
like
your
to put
hunch?
things in everything that's the beginning. So I always tend to bias towards AZA. So if you imagine everybody in scale deciding I really like AZA because it's just the first one that pops up, it would end up with
Yeah.
quite a lot of workloads, imbalance of workloads ultimately across different AZs.
Yes.
So it's just like
I think that is.
yeah,
Yeah, I think
it's just
that's the reason.
yeah, trick to fool us humans into distributing our workloads better.
Yeah. Yeah. By the way, is there a way in which when I create an account, I can specify which AZ IDs map to which AZ names?
I can't remember. I don't know if you know, Alex.
No, you can't. You
Yeah.
can't.
Okay, so that's why
Um,
I don't remember. I know you can identify. So if I think I
yes.
have it here. So let me pull that up very quickly. So here's an account. You can see the zone mappings in multiple places. This is under EC2, and there's a settings section. In there, you have a zones section,
Hmm.
and you can see this is London. No, yeah, London. Uh, how we're doing the mapping. So actually, AZ1 seems to be C, AZ2
Hmm.
A, AZ3 B, and then we have the local zones in there as well. Oh, wavelength zone in this case.
Yep, that's true. So the next question. I can't choose those AZs, right? But if I have multiple accounts and I want to stick to certain AZs, align AZs, quote unquote, I can still do that, right? By controlling where I deploy my subnets, taking into account this mapping, right?
Yeah, yeah.
Cool.
You have to use those, and there's multiple times where this is useful. One is if you want to match to somebody else's account, but it's also some services, specifically networking services, when we require you to match availability zones
Yeah.
with a third party, for example, and then it becomes really hard to try and coordinate. Hey, what's A for you? Oh, okay. So this was launched purely so that it's very easy now to know which one is your AZ1, and then you tell the other party, "Hey, I'm an AZ1. Look at your AZ ID. Make sure you're in the same location."
Got
Yeah, I
it.
see
Okay.
folks popping in the chat some of the services that we're going to touch on in a second on uh,
Yeah.
what they need AZ mapping.
There's an interesting question here. Can you see percentage utilization for a specific AZ?
That's interesting. So what do we mean by utilization? I guess the best way from a networking perspective, you could look at the IP utilization, probably. That's what I would think about. So there's ways in IPAM, for example, IP Address Manager, you can track kind of how your IP address space is allocated across different resources, and you could also see across different subnets. I guess even if you look at your subnets, you could see like how utilized each subnet is or how many IP addresses are left. But it's a little bit more of a subnet by subnet basis. I don't know, Alex. What else would you think?
I I think that the question was more around, and Punchar 4161, let us know if what you exactly meant by utilization. If it's more on the AWS side of utilization, as in like how used that AZ is from instance types and instances used by customers, the answer is no. And the reason for that is because we do plan capacity, like capacity management is something that we do on behalf of our customers. So you should not worry about, oh, do I have capacity in this specific AZ? We're doing the scaling for you and worrying for that for you
Yeah.
or on your behalf.
I think the only thing you need to care about, so I bias towards what do you have to think about your own resources
Mhm.
and your own utilization. But you're right. If it's our side of the responsibility model, then we take care of that. I would say we're obsessive about
Yes.
security and capacity planning. I think that's when you talk to internal teams, that like making sure that everything is secure and then making sure that there's enough capacity to be able to accommodate load.
Yep, exactly. Especially in this day and age when everyone wants GPUs.
Yeah. Yep. 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 Um, okay. So I think the fundamentals are pretty straightforward. The biggest thing that comes up is those AZ mappings and then the latency. Typically, what we recommend customers do, like when you have workloads, we would recommend that you have workloads across multiple AZs. So that's one, right? If you deploy a workload in a single AZ for EC2, I think a single instance SLA is something like 95%. I can't remember off the top of my head, but it's really low, which means that single AZ is not a highly available way to deploy things. As soon as you go multi-AZ, a bunch of SLAs will trigger. For like EC2, I think you're 99.95 or 99.99. And a bunch of other services, including networking services, start triggering their SLAs or start supporting SLAs as soon as you go from one AZ to multi-AZ. So we absolutely recommend you do multi-AZ. The flip side of it is if you are multi-AZ, try and stick to an AZ that you're already in, right? Because as soon
Yeah.
as you start doing massive replication or bouncing traffic across AZs, right? So imagine you have multiple workloads in here and you end up bouncing across different AZs as traffic comes in this AZ. You're not only paying a latency penalty for each one of these journeys, you're also actually paying for data transfer between the availability zones.
Hitherings here has the hi herrings, sorry, has an interesting observation. It would be cool to have at least some colors showing AZ in red, AZ being green, for example, AZC in purple. That's actually such a cool thing for the console, just to see like how your workloads are spread across AZs. That'd be a cool idea. I like it.
Yeah. Yeah, color coding like the drawing. I didn't even color code it in my drawing. Just kept it everything
Exactly,
dark.
exactly, exactly.
Um,
Cool.
so
Um,
the other question is, how do you keep your workloads sticky to an AZ? Because that's usually the next task, right? How do you make
I
sure that?
think before
Uh-huh.
before we go to how you keep workloads within an AZ, I would say this comes up quite a lot. What would you recommend? Okay, multi AZ makes sense, but would you recommend two AZs or three AZs or more?
SLA wise, as soon as you have more than one, you have your
Mm-hmm.
SLA, right? So that's
Mm-hmm.
already good. Uh, it's an interesting question. I would think about it more as kind of capacity planning. Because if your workloads are in two AZs, then one AZ takes out 50% of your traffic, right? So if
Mm-hmm.
your capacity is 50% decreased, and then if you have auto scaling and other mechanisms, you're trying to kind of recover that capacity, or maybe you're running a little bit over capacity to take care of any failures. So the more AZs you have, the least impact a single AZ failure is going to have on your workload. So if three AZs and one AZ fails, then 30%, 33% of your workload goes down. So I would think about it in terms of availability, and how much are you willing to sacrifice in case there is an AZ failure.
Cool. Okay. I think another reason, or what I usually recommend, is at minimum go with two. The three aspect is comes up quite a lot in workloads that need to establish quorum. If, like, you know, that you have two out of three things that need to agree on. If you just have two things, establishing quorum is harder. So usually you would have, I don't know, three nodes in a database, right, that elect a primary, and so on. So there's types of workloads for which quorum selection is important. So having three of that thing makes sense, and having them three across three different availability zones makes sense as well.
Yeah, that's a good point.
Um, there's a TechField here says I always choose a mix of three or four because of our integration with VPC Lattice Cross, VPC Resource Access. Curious to understand. I don't know if three or four because of resources.
Yeah. So 3 or 4, I think PrivateLink is one where you probably need to think about using more, and especially if you're a vendor and if you're doing something between like
Mm-hmm.
parties that you don't manage. Lattice is a little bit, or specifically resources in Lattice, are a little bit more forgiving. There needs to be a single AZ overlap, but you don't have
Mm-hmm.
to overlap all of them. I think we can jump into that and kind of draw that up in a second. But I'm curious, Alex, if you have any like tricks up your sleeve of how, when you're talking to customers and they're saying, "How can I keep my traffic zonal?" Right? How do I end up not
Exactly.
adding latency and paying as the traffic comes in? What's your
Yeah.
recommendations?
Um, Before that, I think TechField clarified, so because of a minimum overlap, but at least one easy for the RGW. Totally. Um, how do you keep workloads within an AZ? Uh, that's a that's a tough one. I would first ask, why do you want to do that, and what is the benefit of doing it? Right? What are you seeking by keeping that traffic within a single AZ? Are you, if you are seeking, if let's take an example, right? um let's say you have some workloads that are clients, and then you have a load balancer, and that load balancer has targets across multiple availability zones, right? um would you do cross AZ load balancing? Would you keep the default with not having cross AZ load balancing enabled? Like, keeping traffic within the same AZ is technically good as a default, but should you go out of your way to say, I'm going to go now and align all the accounts that I have in my organization, and like go out of my way to try to keep traffic within the AZ, or not? So I think that question has an answer of, it depends what you're trying to achieve, right? Like, what is your why,
Yeah.
right?
Typically, what I see is the why is having zonal affinity means that you're not suffering if there's a failure of one of the AZs, right?
Mm-hmm.
So if we're going back here, if you end up bouncing between these AZs, so say a request came in blue, um, and then you hit a workload, and then there's instances of this workload in the same subnet or in the same AZ, but instead you're kind of allowing it to bounce AZs because you're just doing DNS lookup and you're picking one of the IP address from the list of what the next hop is going to be. You're ending up potentially getting affected by weird issues in different AZs, right? So that's one
Mm-hmm.
thing. You're adding latency to every hop, and then you're paying for the unnecessary data processing, even though the same application that you're trying to get to might also have an instance in the local AZ.
Mm-hmm.
Um,
That makes sense. Okay. Uh, Coming back to the example with the load balancer,
yeah, so
and
I just drew it right now. So this is a load balancer, network load balancer. It has 3 AZs. Each AZ has some sort of IP address for it. So IP1, IP2, IP3, right? And then it has some targets, target 1, target 2, target 3, and actually maybe there's more than one in each AZ.
yep.
So the first tricky part is, so how would we keep traffic zonal in this kind of scenario flow? Let's say we have a client in AZ2. So that's some EC2 instance. The first thing it's going to do is do a DNS lookup of the DNS name for the NLB. So NLB does region Amazon AWS dot com. So I'm going to shorten it nlbaws.com. So, and it's going to get back all three IP addresses, 1, 2, and 3. What it could do, so let's do a kind of a worst case scenario. So what it could do is it could pick one, not the one and not its own AZ, because it has no clue about which IP is in which AZ by default, and it just ends up crossing AZs. We're adding latency here, and we're paying. Let's say the NLB itself has cross-zone load balancing enabled. So that means that it can, each NLB AZ can see targets in all of the other AZs.
Yep.
And it will do round robin load balancing across all of those. So what will happen with this flow, let's say again, worst case scenario, let's say we're going back to the target in another AZ because we happen to be load balanced down here. And NLB has no, right now, there's no bias you can introduce to say on the NLB that, okay, maybe prioritize one AZ majority of the time and then just on the back end fall back to something else. Right now, it's round robin across all of it, which means 66% of your traffic is going to cross AZs, or keep traffic in the local AZ. So we actually ended up coming from AZ2, going through NLB and AZ1, and landing on a target in AZ2 again, paying the penalty and paying the cost for traversing the traffic unnecessarily twice.
Got it. Okay. That makes sense. Um, if we
So
go back to the capacity question, though, if let's say you have a capacity imbalance between AZs, that would be a reason why not to not keep that traffic within AZ, right?
yeah, that's a very good point. So let's say we have 10 targets here, but 100 here. We'll just make an extreme capacity imbalance. All right. So if in that way, anybody who ends up landing on AZ1 and we're not doing cross-zone load balancing, we now only choosing from 10 targets, where if we were to land on 2 and 3, we would be able to have a lot more targets. And then DNS distribution, let's say it's an ideal world 30% per AZ. That means that we have quite an imbalance. These 10 targets in AZ1 are going to get hit quite hard compared to the other 10. So if you do disable cross-zone load balancing, it's on you kind of to make sure that you're going to have enough capacity in all of those AZs, and it's ideally matching.
Yeah. There's another question here, which I think is connected to this, and it's a bit longer, so maybe we can whiteboard this one too. I'm running a workload in a local zone where managed NAT gateways aren't available, so I use an NAT instances my egress being restricted to one zone. This is my single point of failure. Without the second AZ for standby, how do I design self-healing egress path? Should I focus on automation to trigger replacement if the instance fails, or is it a better way to route traffic out without relying on a single fragile EC2 box? And this is a question related to the local zone piece.
Yeah, I
It's an
think we need.
interesting one.
Yeah, do we want to take a side? Maybe we can. I want to just finish the NLB. I think because we started this
Okay.
conversation,
Okay.
but I like
Perfect.
that as a sidebar. So we're going to jump into that next.
Okay.
Okay, so there's better ways of this because there's also now a way on the NLB to do AZ aware DNS, right?
That
So
was
you
my next
can,
question.
yeah. So this client, if you enable AZ aware DNS on your NLB, what it will do is it will, as long as the client is in AWS, right? I can't remember if it has to be in the same VPC or will it work over peering? I'd have to double check. But let's assume the client is in the same VPC and they do a DNS lookup. With topology aware DNS, it will be able to provide the IP address of the AZ that the NLB is in. So if this client is in AZ2 and they do a DNS lookup, the IP address they're going to get back is going to be 2. So they're just going to hit the NLB in the same AZ. So we're saving the risk of potentially bouncing around AZ1 and AZ3 unnecessarily, right? We're just staying in the local AZ, not paying the latency penalty, not paying the cost. So that's the front end. I think that's a pretty cool feature. I would hope that we would have this across more services to make life easier for more customers.
Private
Uh,
link.
yeah, maybe in the fullness of time. Let's see. If
Yeah,
that's something
yeah.
that folks like and are interested in for our services, we would love to hear your feedback. So just let us know, let your account teams know. Um,
There's also a good question. Can LBRA we do cross region and keep traffic private? Hmm. Interesting. So
uh,
good. So many good questions. Which
yeah,
one do we want to tackle first? Should we go back to the LV one first, given that we owe it,
yeah,
and then this one?
yeah. Let's do the local zone, and then we can jump to Kodo Shon's question. So just to close this off, if you disable cross-zone uh, load balancing, the traffic is going to stay in the same AZ and go to the targets here.
Mhm.
Now, the risk of no cross-zone load balancing is also that if all of these targets fail, this zone ultimately becomes unhealthy. The good news is with NLB, we would remove that IP address from the DNS. So if all of a sudden all of your targets are down or NLB itself in that AZ becomes unhealthy, even with the NLB uh, zonal DNS, we would still return now a healthy IP address in another AZ. So you could, in case of failure, switch to another AZ, but you don't have to be bouncing around AZs unnecessarily unless there is a failure. So I think that that's a really neat pattern. So
Yeah, very cool.
okay, I see Jamie's crushing our show.
Yes. Hello, Jamie. Hello, hello.
All right. Okay, so the Loverins. Okay, so the question was about. We want to pop that up on the screen for a second.
Yep, yep, yep.
Yeah.
We have a workload in a local
Yep.
zone where managed NAT gateways are not available. So they're using a NAT instance. Is there egress?
Okay. So we have a local zone. We have a NAT instance. Uh, not.
And by the way, a local zone is like an AZ. You create a subnet that's tied to that local zone. You spin up the instances in that subnet. So very, very from an experience perspective, it's very similar to an AZ.
Yep. And then so what you would have is you would have a subnet for the and then you have an IGW. So you can break out
Mhm.
to the internet from the local zone. You have your NAT instance, and then you would have a subnet. Let's call it the source subnet that you're sending traffic from. Let's put it in EC2 instance here. So you'd have to update your routes and say that if you're going out from this subnet, you need to go to the ENI of your NAT instance. This route, as folks probably already aware, is not health aware. So that will drop as soon as there's an issue. No, not drop, but if the ANI is down or if instance is down, that route doesn't have any awareness and it will send traffic to a black hole. So if this instance has a failure, um, you do need to do some sort of auto recovery yourself. So there's two things that you need to focus on here: detecting the failure. So how do you make sure that the instance is healthy? How do you realize that the target is not available because the route is not going to tell you? And then recover. So how quickly you can create a new instance, and then what do you do to navigate traffic to that instance? Detecting, I've seen a bunch of different ways of doing it. Could be as kind of simple as just detecting if the instance has an issue or not. But if it's some kind of issue with the software on the instance itself, right? So the EC2 itself is healthy, maybe the OS is healthy, but the process running nothing is gone, or whatever you're using for doing nothing is, if there's a failure there, you might have to have another mechanism to be able to detect that it's unhealthy. Could be something like a Lambda function that's actually trying to send traffic through the NAT gateway. Could be something that's actually connecting to the service itself. I
Could
don't
it
know, Alex, if
be?
you have other
I
things
am
you've
just
seen.
thinking now, and I don't know actually. So I haven't tested, and I don't know if it works. But could I use?
Route
Actually,
server.
I don't think route server. Yeah, but I don't
Yeah,
know if the endpoint is available in local zones.
yeah. I think you.
Hmm.
Yeah. So let me just add a route server. So there's a. We can double check, but that's an interesting. I was thinking about route server as well. So if this is like AZ1, so an AZ in the home region, and this is a local
Hmm.
zone somewhere further away, uh, a route server. I'm just going to draw it here. Route server has an endpoint in one of the subnets and can talk BGP. So in theory, you can set up a BGP session, right? eBGP here
Technically,
between
yeah.
between your NAT instance and the route server. And then
Hmm.
you can tell the route server which subnets to populate with routes that it learns from this NAT instance. So you could point it to the subnet and the route table of the local zone. So in
Hmm.
theory, I haven't tested it myself. It sounds like you haven't, Alex, either. But in
I
theory,
haven't, I
route
haven't. But
server,
if anyone knows, Jamie, you're here. Jamie, go, let us know if you know, or if anyone else who's following us knows
yeah,
and has tested this. Let us know if it works.
yeah. So VPC route server is pretty much basically the ability to use BGP to inject a route to a route table of a subnet. So you could then have a second NAT gateway. So you would have to run at least two. So I guess it depends how eager you are to do fast failover. Both would advertise a route over BGP, and both would advertise a route to themselves. So maybe ENI-X and ENI-Y is the secondary. So route server would see both. It would see ENI-X default to ENI-X and default to ENI-Y. It will pick the best one and inject that into the VPC route table. If there's a failure like here, the BGP session goes down, route to ENI-X goes down, the route server now can see that ENI-Y is better, and it will update the route table to Y. It actually happens pretty
Very cool.
fast. There's bidirectional forward
BFD, bidirectional forward
BFD. Yeah,
detection.
BFD is enabled, so you can, the actual detection of an issue is super fast. I think the time you have to wait is for the route server to actually implement the change in the VPC route table. But it is a way to automate the failover and also automate the detection, because it's likely that if the BGP fails, it's either the worst case scenario, if a BGP process stays up but something goes wrong with the NATing itself, but that's a weird failure scenario. Most likely is the instance going to go down, or um, more things are going to fail that will take the BGP session down.
Yeah, pretty cool.
Yeah,
Awesome.
without the route server, you're kind of more in the world of detecting it yourself
Yeah,
and then recovering it yourself and then updating the route yourself or moving the network interface. So this network interface can actually move between instances. So that's another option. Whether you're changing the ENI between instances or updating the route, I think the time it takes, it's kind of similar. I think it might be a little bit faster to change the route to a new destination than to move the ENI.
yeah. There's a funny comment here with stay in the pursuit. Are these basics?
Yeah, we
We
started with the
started from
basics.
basics. Yeah.
It's a good
Networking
call out.
has the potential of becoming very complicated very fast. So let's go
Yeah,
back to basics.
yeah. Thank you for
Um,
keeping us honest. Yeah, we definitely appreciate that. Uh,
Also, Jamie, our NAT, regional NAT, doesn't work with local zones because NAT gateway doesn't is not supported in local zones. So, hmm. Cool. Oh, and there's one more question, and I want to make sure we clarify this before we move further. For the previous example with the network load balancer with the DNS, DNS queries are not by default easy aware, right? We've talked about this, so you're not going to
Correct. So
be.
going back very quickly here, we were talking about how the DNS of the NLB can be made AZ aware. It's a setting of the NLB. So there's the question, okay, if it's registered with RT3, how does cross-zone load balancing interact? Two separate things. So think about the DNS front end being how do you select which NLB AZ you're going to land on? And you can make that AZ aware by changing the DNS functionality, ultimately enabling a DNS aware, AZ aware DNS on the NLB. And it's separate to what you do on the back end. So you could enable ASIO aware functionality on the front end. So that means if your client is in a particular AZ, it will bias towards the local AZ. On the back end, you can do cross load balancing if you want to do that, right? And spray traffic across all AZs. Or vice versa, you can not enable ASIO aware DNS on the front end, but keep it static on the back end. So these are two independent decisions that you need to make. And they both affect, again, the latency and cost there.
Yep. Question from Ken, and I think we should. Can we have a dedicated session on local zones? For sure. That will definitely become complicated really fast.
Yeah, I feel like the session on local zones is going to be like, which local zone are we in, and what capabilities this zone happens to have compared to the
Yes.
regular zone. That's usually what it is with local zones.
Yeah, yeah. I use a lot of um I don't know, Claude to answer these questions for me because I have no way to track everything and see what like remember what features in which AZ or local zone, and I'm always asking, "Hey, is this thing available in this local zone?" Yes. Go search the documentation.
Yeah. Let's do maybe expand the NLB example for PrivateLink because that's also unless we had another question that we were supposed to go back to, but I think we touched on all of them,
No,
right?
I think we're good. If you
Okay.
folks haven't had your questions answered, please put them in the chat. Um, Time flies when you're having fun. It's 10:41 or 11:41 already, Pacific time. So we only have maybe 19 minutes. So yeah, let's expand on the NLB.
Okay. So NLB also is the building block of PrivateLink.
Mhm.
So the regular PrivateLink or VPC endpoints, I feel like the naming we use very interchangeably and it creates confusion sometimes. So PrivateLink is what powers a lot of this like private magic under the hood. And officially it's actually VPC endpoint for NLB and VPC endpoint services, but everyone's calling it PrivateLink. So ultimately NLB has the ability, and I'm going to draw a VPC boundary here because we didn't need that before, but we need it here. So we have a VPC1 here, and then we'll have a VPC2. uh, NLB allows the listener or the kind of like IP address that you're hitting to be extended, like as a magic extended arm into another subnet in another VPC in the same region, as well as now cross region. But let's focus on the use case where we're assuming this is the same region because that's where really the availability zones come into play. So if the load balances was listening on port 443, then that listener extends here. And if this VPC was in the 10 range, there's going to be IP address in the 10 range that's representing the NLB, even though the VPC of the load balancer might be in a different range, so it might be 172.16. And then same as before, the NLB can point to a bunch of targets, right? Now, I didn't draw the NLB in the third AZ to illustrate the fact that if I'm a consumer of this NLB endpoint service, I'll be allowed to create endpoints in all the AZs where the NLB exists because it has to be a one-to-one map. I can't create an endpoint across AZs, and I will
Back
also have.
to back to how we talk about things. You can create an endpoint with multiple availability zones associated to it in those AZs. The reason for that is because I've seen quite a lot of customers who are actually trying to create two VPC endpoints, separate VPC endpoints, one in AZ1 and one in AZ2. It's just one endpoint with two ENIs, one per AZ.
Actually, that's a good point because you could do both, and we won't stop you. Uh, so this is considered an endpoint, and these are ENIs of the same endpoint,
Mhm.
and then the NLB is considered an endpoint service. Okay, I'm gonna clean that up. Um, so what happens with that third AZ, right? It's a bit of a problem now because if you're let's say you're a provider of a service on the right hand side, right? You have an application that you want your customers to consume from AWS from all of their AZs. They cannot create an endpoint in this AZ unless you extend your NLB in this AZ.
Yep.
So what partners often do is they would deploy the NLB across all available AZs in the region because they don't know which AZs the end customers happen to use. Right? And that way, I can now, as a customer, if I happen to use AZ2 and AZ3, but not one, I still can have multiple endpoints and it works. The question now becomes, this AZ is dead because I don't have cross-zone load balancing enabled. So I have two choices as a vendor. add the capacity in this AZ
Yeah.
and don't do cross-zone load balancing, or enable cross-zone load balancing, which is a setting for the whole set of target groups, and then everything is doing cross-zone load balancing, which means now I have additional latency for some traffic, and then I have to pay for the traffic going to crossing the AZs. But
Yeah.
this allows me to make sure that I have capacity. I'm able to expose the ability for my end customers to connect to my endpoints in every AZ.
So would you recommend I do customers do this, or they actually put capacity in all AZs?
There's no silver bullet I've seen. It both work. It depends how hard it is to put your capacity in another AZ, and how large your customers are, or like which AZ they bias towards. So there's more considerations here. So I haven't really seen a one size fits all here.
The most common one that I've seen is enabling cross-zone load balancing.
Yeah, it's the easiest one, right? You take
Yeah.
the cost on, and then you use the capacity you have. Fun fact here: if I'm a client and I cross AZs to consume an endpoint, we don't charge for this anymore.
Yeah.
So there's no
That's good.
cross-zone data transfer charges for a client connecting to a PrivateLink endpoint, not to an NLB. With NLB, that still exists, but if you're going to a PrivateLink endpoint, there's only a latency consideration, no longer a cost consideration.
And that's actually good because by default, on the client side, when the client resolves DNS, there's no AZ awareness.
Yeah.
So
So I'll do a DNS lookup. I'll have all 3 IP addresses, and as a client, I don't know which AZs they are, and I'll hit whatever AZ at random. The one call out. So there's no data transfer. The endpoint itself has data processing. So I want to make sure that we don't confuse the two. So there is no cross AZ data transfer charges here, but this is a managed service that processes your data. So there's a separate data processing fee on the PrivateLink endpoint itself.
yeah, yeah. Can I still do AZ affinity if I want to on private link endpoints? I think you can
Yeah,
use
so
the
there are
AZ
host names.
level.
Yeah,
Yeah.
so when the endpoint launches, there's multiple host names. We actually provide you with host names that are AZ specific. So if you really want to make sure your traffic stays in an AZ, you have to make sure your clients use an AZ specific host name.
Is that a recommended thing? What happens if that CNI doesn't is not
Yeah,
available
you have to
anymore?
build your own logic in there. Yeah, it's a tougher sell, right?
Yeah.
But you have the
Cool.
choice. So you have the ability to hit the local endpoint, but if you can configure your clients to try the local endpoint first and then try something else, that's ideal.
Cool. You could do some client side load balancing.
Yeah.
Or
Yeah.
whatever
Do we want to
affinity.
touch very quickly on resources? Just looking at the time.
Yes, yes, because Lattice does like both for resources and services. For services, actually, even more permissive than resources. Abstracts completely your availability zones, so you don't have to overlap AZs. It's all nice. So yeah, do you want to talk about both services and resources?
I think because in services it really doesn't matter. So do we want to talk about the one that matters, which are resources?
We can start with resources, but I want to touch on services
Okay.
too.
Okay. So how do we present Lattice? So with Lattice, we just chatted a little bit services and resources.
You can do the same to VPCs and just
Yeah, let's do that.
present a resource from a VPC on the left.
Uh, VPC 1 and VPC 2. But so Lattice is like two of those services in a trench coat. Services which are HTTP applications, and then resources which are kind of TCP applications. So the comparison could be services are like ALBs, resources are like NLBs, but they wrapped into the same container of Lattice service network. So we have our two VPCs. Let's do different colors. We'll do Lattice service network, and then maybe we have, what do you want to put on the, like,
Let's put a database.
let's start with uh just get another color. So let's say there's a database here. and then
Like an
maybe
RDS database across two AZs
yeah,
with like a main or the primary node. Yeah.
yeah. And then we're starting with resources. So this is going to be TCP access. So for that, we need another construct inside of the VPC called the resource gateway. And then just like with any other things that you deploy in the VPC, you have to select the subnets and the AZs it's going to live in. So let's say I decided to use AZ1 and AZ2. Uh, ultimately, oh yeah, this is the service network. It lives logically outside of the VPC, and you can think about it as a container for um, for all of the things that you're trying to expose. And then on the consumer side, let's stick to endpoints. You can also use an endpoint to connect to the service network. So similar to the PrivateLink endpoints, actually under the hood is using PrivateLink technology. So one caveat here is when I'm creating the ENIs for the endpoints, so when I'm creating the subnets, I have to overlap at least one of the AZs that I have the resource gateway in. So I wouldn't be able to just successfully deploy an endpoint in here and be able to use that endpoint to access things through the resource gateway. I have to deploy endpoints in at least one other AZ that overlaps. So, or ENIs for that same endpoint. So if that will work, no problem. And then I can have a user here crossing AZs, hitting the endpoint, coming through the resource gateway, and then resource gateway can connect me to, if this is the primary, to secondary.
But that is though if you choose to create service network endpoints or resource endpoints. Because if you do the service network association, then that association doesn't have an AZ specific thing. So it
Yeah,
just works for your entire VPC, which completely abstracts your AZs.
yeah. So if you are connecting just from the local VPC and you don't need to connect from the outside, you can just create an association to the service network. I don't know how the best way to draw it, but I'm just going to draw it like a kind of connection between all the AZs and the service
Yeah.
network. So at this point, you don't have to care about availability
Yeah.
zones, deploying anything in AZs. You're just creating a VPC to the service network association. And then as you expose these databases, you're saying uh, you're dropping them into the service network as resources, as resource configurations for your database. And then
Mm.
that's going to listen on a specific port, 1532. And then you can, the user can connect
Yep.
to the
And
resource
the service
configuration.
network association keeps traffic within the AZ. So if your client is in AZ1, who's going to go with the traffic to the service network to AZ1 to the resource gateway to the database. So not a not a worry there around AZs.
Yeah. I guess if you were to expose a service, like it's kind of more similar to this association where we magically connect to a VPC and letting the service network connect to whatever thing you have on the back end here. So maybe I have an
So
application load balancer,
you can think as the service as being that application load
EC2
balancer,
or
right? That
EC2. Let's say I have two EC2s.
we take and deploy it across all AZs. Like you don't have to worry about it. So whatever your EC2 instances are in the backend, or whatever you have as targets, pods, tasks in ECS, etc. The load balancer is automatically deployed across all AZs. So you get that routing across all AZs to your targets.
And you have to also define it as a service association.
Yep.
So I guess the rule of thumb is if you're doing resources which are TCP, you do have to think a little bit more about that network connectivity. Think about where your resource gateway is going to live, which AZs, versus services. As long as you register a service and as long as you associate the service network, you don't really have to think through availability zones.
Yeah. Um, Call out here when Tom says magically connects. That's scary. There's so much going on behind the scenes. Totally. But at the end of the day, I think we live in the day and age where whatever happens under the hood doesn't matter as long as it magically works. We're good.
Whatever happens under the hood stays under the hood.
Exactly. Exactly. Right. Oh
Uh,
man.
I wanted to touch on Transit Gateway as well. I don't know if we have enough time because there's
Mm.
some interesting stuff with how Transit Gateway deals with AZs.
We have exactly 4 minutes. Should we have another session on this?
Yeah, we could weave it into another Ask Me Anything session or whiteboarding session
Yeah.
where we could also maybe take additional questions from folks joining in
Totally, totally.
and
I
just
think there was
whiteboard.
a lot of engagement here. We can talk about regional NAT and how it deals with availability zones because that's a really cool way. We can talk about inspection with Transit Gateway as well and the appliance mode setting there, which is
Hmm.
really, really interesting around AZs. So I think yes, we should do another session around back to basics number two, AZs for all these other networking services.
Cool.
That'd be amazing. Awesome. Love it. Well, thank you so much, folks, for your engagement today and for all your questions. It was great. Thank you, Tom, for joining me here and being a really nice guest, not just moderator, and letting me ask you all the questions. And yeah, thank you so much, folks, and see you next week.
Thanks, everybody. Thanks, Alex.